record. Okay, I'm sharing with you the things. Okay, so I need to share with you this one. Where is that? Okay, so wait, screen. Wait, hang on. Okay, so hang on, this is not correct. Wait, I just need to wait, Okay, can you see you can see the book, okay? So let's very quickly go through from the beginning, okay? So we started here with our with the health related and the difference between the athletic ability components. I hope that one is understood and why you need to make sure when you're starting an exercise program for your client that you have all those components in mind, yeah? So you do not focus only on one factor, you will combine all of them, okay? So stamina, the body composition, I made a mistake in the recording yesterday. Obviously, this is not, the body composition is the relationship between the lean mass and the fat mass, okay? And I think I said lean mass and muscle, okay? So that's a typo, let's say, a verbal typo. Okay, then flexibility, strength, muscular endurance, and stability. So this is for your average Joe, and on your right side is the one when you have athletes to train. You need to have in mind that you're adding these components as well. Yesterday, when we started with this one, most of you were like a little bit, I have no idea what she's talking about, but I think during the training, you did understand in the end what all this means. Yeah, so the first one, it increases your VO2 max, okay? So your stamina gets better. The way how you deliver the oxygen to your working muscle during the exercise increases. The volume of your air or oxygen, what you in an exhale per minute will decrease, because initially you're going to huffing and puffing when you start exercises. And then after a while, when you're getting a bit more more fit, you're not huffing and puffing anymore. So this one will decrease. And the same also with your heart muscle. So the heart muscle also consumes oxygen, and it will also decrease that the oxygen cost. Yeah. So this one also decreases. So your heart will not use as much oxygen as it needs before. Then it reduces your heart rate. Remember, we talked about the pulse. The fitter you are, the slower your heart rate gets, and it also decreases your blood pressure. It increases the capillary density in the skeletal muscle. Remember, we talked about the capillaries, like the small blood vessels. Then it will increase the exercise threshold for onset cardiovascular diseases, so you get not so sick so fast. It will decrease the insulin needs. Yeah, usually an unfit person, when they start exercising, they need more insulin in order to get this blood sugar converted into the cells for energy, and that one is not needed when you are fit. Okay, it increases your good cholesterol. Remember, I actually said that the high density lipoprotein, the HDL, is actually not cholesterol. This is the bus or the taxi, it's the Uber. Yeah, so it's a grab car for the cholesterol. It just transports it, but we will talk about cholesterol when we talk about nutrition. It will decrease your serum triglycerides, which are your fatty acids, which is the triglycerides is the stored form of fat. Yeah. So it's actually your sugar. If it is not needed as energy, it will be converted into fat. Okay. And then the rest, I think that one we don't need to go through, right? Anxiety, depression, enhanced well-being, and blah, 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 blah. I think that's cool. Okay, so we talked about the 5 primary functions of your skeleton system. This is, you need to know for your exam. We went through the difference between the different bones. Okay, so we talked about that. So again, the finger bones, like the metacarpals and the phalanges, and also your, you know, in your feet, that little bones you don't need to know. Yeah. So concentrate only on here, humerus, radius, ulna, carpal, sternum, shoulder blades, like scapula, stuff like that. Don't waste time, you know, with your little bones in your fingers. Okay. Then we talked about the structure of your joints and how the joints actually connecting the bone. They are connected bone to bone by ligaments. Then the connection with your muscle to the bone is tendons. And we talked about the structure of the joints. And we talked about the different kinds of joints. Yeah, so we have 6 major different types of joints. And the joints we are talking about during exercises, they are called diarthrosis or synovial joints on the left side. Yeah, I cannot find my laser point. I don't know where it is, but you can see my cursor. Yeah, can you see that? Okay. Can everyone please switch on the camera except of Q? I have no idea how to pronounce your name, so I just call you Q. So Q is exempt because she's at work and she can't switch on your camera. Yeah, so everyone else, please turn on the camera. Belinda, let me.
I don't know also what happened to my camera.
Shy. All right. Good. And then Angel is there. Where else? Who else is there? Ah, there's still people missing. I think 3 or 4. Okay, never mind. We just go on. Yeah. Okay. So again, different joints do different movements. Some joints are not so flexible. Yeah, hinge joint, for example, in your elbow only does 2 movements. It flexes and it extends. And shoulder joint and hip joint is a ball and socket joint. That's the most movable joint in our body, and so on and so on. So, and depending what joint you have more movements. Then we talked about planes. And you only need to know the 3 planes. In your book are 4, and yesterday we added on the oblique plane as well, but you don't need to know that. So basically the oblique plane is everything if it is not sagittal, frontal, or transverse. Transverse is also called horizontal. Yeah. So this is important when it comes later, when you are programming your client, so that you are programming the client that the exercises are in all planes where the joints go. Yeah, so you don't want to do, let's say, for example, only a front lunge. A front lunge would work the legs only in one plane, which is your sagittal plane. So you may want to include also a side lunge, because then you would work your frontal plane, and so on and so on. Okay, that is the reason why you need to know that. And then we talked about the terminology. Yeah, and we went through all of this, what it means. And this is important also that you know that. I'm not 100% sure if they will ask exactly, you know, what exactly is an abduction, but they will give you exercises and they will use this one, and, you know, they will use this term. So that's why you need to know what it means. Last time in the exam, they ask, if you are pointing your palm away from you, is it in flexion or is it in extension? And it is in your book. Yeah. So we added it. So basically, this is something you need to you need to just know. Yeah. So when it is up, extension away from you is up, and this is a flexion. Yeah. So, but here the gentleman, he also shows you everything, what it means. Then we talked about the heart and the lungs. We talked about the heart rate and the blood pressure. And also we talked about the cardiac output and stroke volume. However, we will cover this again when it comes to cardiovascular programming. Yeah, because this one is something which will change a lot if someone, particular if we are doing cardiovascular exercise, will increase. Yeah, so and normally at rest, it is about 6 liters for both fit people and unfit people. It's not much difference. The difference comes once they start exercising. Then the fit person will deliver or will pump much more blood through the body than an unfit person. And the blood contains oxygen. And when there's more blood with more oxygen, obviously you can have a better performance. Okay. Does it make sense? Yeah. So, and here is this example. Yeah. So with a couch potato, yesterday I told you the example with twins in case if I gave you the example with the twins. So both of them watching Netflix, it's 6 liters per minute at rest. And when I start exercising, most likely the couch potato will have an average, cardiac output per minute of 20 liters, whereas a fit person can have up to even 35 liters. It depends how fit they are per minute during exercise, and that is 15 liters more per minute what you are delivering, blood and oxygen to your working muscle. That's a lot. Okay. Then we talked about the blood pressure. We talked about what is systolic pressure, what is diastolic pressure. But again, we will go through the blood pressure together when we are doing the practical, because I will teach you how to take the blood pressure with a sphygmomanometer, which is the stethoscope and the manual cuff. Okay, so then we go through again, and you can find out, you can listen, you can hear how it works. Okay, so no panic, everything is covered. Okay, and then we talked about the consideration as a trainer. Yeah, remember we talked about it. There is a difference when you start exercising. The systolic pressure, which is the contraction phase, will slightly be higher. So when you measure a blood pressure before exercise, it is actually better to do that, because when you measure after exercise, most likely the contraction phase, the systolic, will be higher. And that would mean it is not a false measurement, because during exercise, your systolic pressure will go up. The diastolic pressure will not change. Usually the relaxation phase stays roughly the same. Okay. All right. So Belinda also, she's shy. She has problem with the camera. Adam, switch on your camera. We want to see you.
No.
Girls, they are shy. We want to see you, because if in a live face-to-face class, you cannot hide also. Okay. Right. Now, then we talked about the exercise physiology. We talked about the energy system, and that one was towards the end. I think we got all a little bit tired because we started late yesterday. So very quick review. When we exercise, or when we just, our body needs, in order to survive, we need energy. Okay, and energy, the currency of energy is called ATP, which stands for adenosine triphosphate. Okay, that one is in your mitochondria. Mitochondria is your powerhouse in your body. It's the cell which is your factory of your energy. Okay, so that is your factory. Okay, so ATP is in your body, and it will provide energy for a while, but of course it needs a refill. Hi, Adam. See you. Is my camera still on? Because I also had problems with camera. Okay, yeah, mine is on. Okay, if I disappear, let me know, because my camera is for some reason also on off today. So we need ATP, which is in your cell already. Okay, and we have, depending what we do, is we have two energy systems. One is called aerobic energy system, and the other one is called anaerobic energy system. Air is air. Okay, aerobic means you need oxygen. So one is you need oxygen to use this energy system and to use that fuel for the energy. Okay, and the other one is called anaerobic pathway or anaerobic energy system. So the anaerobic energy system, we have two. The first one is ATP PCR or PC system or CP system, which stands for phosphocreatine or creatine phosphate. Yeah. So creatine is a supplement what you also can take. Some people take that to get energy, but this is something, it's in your body. It is already there, and you don't need to eat something that you get it. Okay. It will be converted. It's in your energy. It's there, but it is not there for long. Okay. It only lasts for a few seconds, and then your body will switch on to another energy system. So it goes and takes carbohydrate and will also convert it into energy. Okay. And that is called glycolytic system, but anaerobic glycolytic system or anaerobic lactate system. The reason for that is because when you are in an anaerobic zone, so that means you don't need oxygen, so you can use it for sprinting, for example, there is a byproduct, and that is lactic acid. Okay. And lactic acid accumulates in the blood earlier when you are unfit. No matter whether you do weight training, if you do soccer or you're doing aerobic training, doesn't matter. Okay. For example, yesterday, Camille had a good idea, example. He said, is that the burn? Yeah. So yes, it is the burn. Basically, when you start exercising and you're using weights and you come to a point where it starts to burn, you know already, okay, that is basically the point where you start to build up lactic acid. All right. And that is a sign that you're supposed to slow down. And the same thing also happens when you're doing anaerobic, let's say, sprints. You cannot do that forever. You go a few seconds, and then what happens is you think you're going to throw up. Okay, that is a sign. It's basically your lactic acid is kicking in and forcing you to stop. And you can increase that threshold where the accumulation of your lactic acid in your blood is higher, can be tolerated. You can increase that when you train. Okay. So usually what happens, lactic acid will come into your bloodstream, and then your body will get rid of it again. Okay. And then it goes up and your body get rid of it. But if the lactic acid is higher than your body can, let's say, get rid of it, then you need to stop. Okay. Then your body says, hey, this is enough. You need to stop. Okay. So that one is a sign that you are tired, you are done. And this one you can actually change while training. Okay. Then the aerobic system, aerobic pathway. Yes, Jasmina?
Sorry, I have a question about the lactic acid.
Lactic acid, yes.
Yeah, so means it is also depends on my heart rate. I have to control the heart rate. Is it because what's happened with me in the past? Yeah, I'm in a phase where I would love to run. Then I couldn't stop, and then next day I have muscle pain.
Okay, all right. So yeah, okay. So the thing is, usually the anaerobic zone starts around let's say 80 to 85% of your maximum heart rate. It's called Cavonen formula, and we will go. There is a formula, or there is kind of like a number which we can calculate. And you will learn that when we go through the cardiovascular programming. You will, but there's a good point. Yes, there is, when your heart rate is, let's say, easy peasy. Yeah. So let's say a marathon runner, there will be very easy. Maybe they'll run between, 55, 60% of the maximum heart rate. That is reason why they can go on for hours and hours and hours and hours, because they're using the aerobic pathway. Okay. A sprinter, they go up to 95% of the maximum heart rate. Sometimes when you see sprinters and they're collapsing in the on the finishing line, they took it sometimes up to 100% and they will collapse. Okay, that is what I explained also yesterday. When we do VO2 max test, we never go for 100%. We always go for sub maximal heart rate testing, and you will learn how to calculate this. Good point, Yasmina. Yes. You will learn. It's in your book. It's called Kavonen formula, but we go through this once we are reaching the cardiovascular system. Okay.
Yeah. Thank you.
You're welcome. Okay. Good. All right. So, and then our aerobic pathway. Yeah. So we have mainly, or the fastest way our body, get energy is from carbohydrate. And we are not talking now about what is the difference between complex carbohydrate and simple carbohydrates. Just let it call carbohydrates, okay? Nutrition we will cover later in nutrition. So you have carbohydrates that one is available in your blood as blood glucose. It is available in your liver as liver glycogen, which is the stored form of sugar. And it is also stored in your muscle as muscle glycogen. And these three, muscle glycogen, liver glycogen, and also the blood sugar, are the most immediate form of fuel you have during exercise. Okay, so it is not that you're taking first out the blood sugar and then you take out the sugar from the muscle, and then you take out the glycogen from the liver.
Sorry, Simon, can you repeat back the immediate source for as a fuel for when we work?
Yeah, the most immediate form is carbohydrates. Yeah, when we exercise, or when we not exercise, when we live. So our body uses carbohydrate as energy, okay, in form from sugar. But this is what we covered yesterday. So we are not going to go into details with this, Belinda. You need to go back and check out the slides, yeah? Okay, this is just a repetition.
Okay, thank you.
You're welcome. Okay, so we have carbohydrates in form of blood sugar. We have muscle glycogen, we have liver glycogen. The second one comes in form of fat. And then protein, as we discussed yesterday, it's only in emergency situation, and we only use maybe around 5% of it. Okay? Make sense? Yes? Can continue? Good. So then we talked about, and it is in here as well. It's in your book. This is your book. We are just going through the book now. We will not do the book during the lecture. We are switching to the slides soon. This is just now a repetition from yesterday, okay? Then we talked yesterday about the maximum oxygen uptake, and also about what is the training effect, okay? And now we're going to continue here. Page number 23, Muscular System, and I will switch to the slides, okay? So let's just, I don't know if you see, no, wait, hang on, I just stopped sharing, and then I'm going to go for the other. Okay, so you can see this, yes? Okay, and as mentioned before, everything is covered in the slides according to your book. It looks a little bit nicer because we don't have permission to print out some of the pictures in your book. But everything what you see here, it's in your book, okay? All right? Okay. So let me just double check. I just hope that I just want to put this one to the side. Okay. All right. Nice. Okay. So now we have 3 muscles in our body. The first one is our heart muscle. The second one is our visceral muscle. And the third one is our our skeleton muscle. That is what we're talking about. So the cardiac muscle, it's striated. That means when you would take the heart and cut it into 2 halves and put it under the microscope, you will see little stripes, okay? And it is involuntary. So you cannot tell your heart, hey, heart, you stop for a while, okay? So the same also here, it's involuntary. The visceral or smooth muscle are involuntary. You cannot tell your stomach to stop digesting your food. And the voluntary muscle is your skeleton muscle. And that one is what you can actually, you say, okay, this one, I'm thirsty. I go and I grip the glass and I drink water. Okay. So this is something what we can control with our brain. Okay. So we have muscle, we have bones, we have joints, we have ligaments, we have all this nice stuff, but there's one thing missing, and that is actually the connection to your brain. Okay. So everything is connected to your brain. That's called the neuromuscular system. Okay. So, and I have very quickly a video here, and I hope that you can hear it. You can hear, right?
There are 3 types of muscles in the human body. These are voluntary or skeletal muscles, cardiac muscle, smooth muscle. Skeletal muscles are voluntary muscles. This means you are in control and choose when to contract them. Nerve impulses from the brain trigger the muscles to contract. They attach to bones via tendons and enable movement. Skeletal muscles can produce powerful, fast movements or small precision actions and have the ability to stretch or shorten and still return to their original shape. Fixator muscles are a type of skeletal muscle whose primary purpose is to stabilize joints. For example, the rotator cuff muscles help stabilize the shoulder. Involuntary muscles are found around organs and in blood vessels. We do not consciously have the ability to control this type of muscle. They contract and relax automatically. Involuntary muscles are also known as smooth muscle because they do not have the striped appearance that skeletal muscles have. Smooth muscle is found in the walls of hollow organs such as the stomach, esophagus, bronchi, and in the walls of blood vessels. Involuntary muscles help move food along the esophagus or constrict blood vessels to reduce blood flow. Cardiac muscle is found solely in the walls of the heart. It has similarities with skeletal muscles in that it has a striped appearance, and with smooth muscles in that its contractions are not under conscious control. Cardiac muscle is highly specialized and resistant to fatigue. This is due to the presence of a large number of mitochondria, myoglobin, and a good blood supply. For more information or to test yourself with our interactive quizzes, visit teachpe.com.
Okay, I mentioned it already yesterday. So teachpe.com is the slides what we're using, and also our videos, because you need to be very careful in YouTube which source you're listening to, which YouTubers or Instagrammers you are listening to, because there are a lot of misinformation out there. So be careful. It doesn't mean necessarily if someone has, 2 million followers that they know what they are doing, because I see a lot of BS, a lot. Okay, so be careful when you are doing some research. Just make sure it's a proper source. Okay, so now when you have a muscle, you do have a muscle which is connected to your bone via a tendon. Remember, ligaments is a bone-to-bone connection. Ligaments will attach, tendons will attach the muscle to the bone. Okay. And the part where the muscle is attached to the bone is called origin. That's basically the point where your muscle is fixed on the bone, and there is no movement involved, okay? So that one is basically the point where your muscle is fixed on the bone. The insertion is that part of the muscle which makes when the muscle contracts, when the muscle shortens, which moves actually, let's say, the arm or the limb, okay? So that one is the moving end. The agonist muscle is the prime mover. It's the muscle which is the boss for the movement. That's the chef, that's the boss, that's the guru, that's the master, okay? The sifu, okay? So the agonist muscle is the muscle which is the main muscle which is in charge for a certain movement, okay? The antagonist is the opponent, anti, opposite, okay? So this is the big boss. That is the big boss from the other side. For example, when you do a bicep curl, your bicep is the agonist and the opponent would be your tricep, okay? When you do hamstring curl, your hamstrings would be your agonist, your quadricep is your antagonist. When you do crunches, your abdomen muscles are the agonist, your back muscle is the antagonist. So always the opposite is the antagonist, okay? Then you have some muscles, because the muscles never work alone. They always work in pairs or in groups. These are called synergists, the helper muscles. And you do have stabilizers or fixator muscles, which, as the name says, they will stabilize at the origin of the muscle, so that, let's say, your joint is safe. For example, when you do a bench press, okay, when you do a bench press, the main muscle would be your pectoralis major, okay, because that's the chest muscle, okay, for the chest, okay. So the helper muscle for this would be, for example, your tricep, because your tricep does an extension in your elbows. This one would be your synergist, a helper muscle. Another helper muscle would be apart from your shoulder muscle, which is called deltoid. And deltoid has 3 parts. So when you're doing a bench press, in order to push the bar up, you would have your anterior is the front part of your deltoid, of your shoulder muscle, helping to do this muscle, okay? And when you are lowering down the bar, you need, on the other side, you need also muscle in order to control the movement as well, right? Otherwise, the bar would most likely just hit your chest. So the opposite side would be your lateralis major, which is your back muscle, and it would be your posterior deltoid, okay? So this is, for an example, what I just give you. This is called synergists. The fixator, for example, in your shoulder would be, for example, your rotator cuff muscle. There would make sure that your bone in your shoulder joint stays in the socket. It will not glide out. These are little helper muscles on the origin of your muscle. That's called stabilizer or fixator. They are also helping, but they are not synergists. Synergists helping to do the movement, okay? And the stabilizer or fixators, they are just in the background, and they're just holding, they're just, you know, make sure that everything is smooth. Okay, they are helper muscles, but they're not synergists. It's different. Okay, does it make sense? Can we move on? Yes? Okay, if I'm going too fast, stop me. All right, so this is the same as in your book. Okay, so you do have, again, your bones. Yeah, so you have, again, your bones here. So every time you're studying something, you can, have a look and you go, so you have your bones, and on the other side, you do have your muscles, okay? The muscles we go through, you do not necessarily need all the origin and all the insertions, okay? But it is good to know what is the name of your chest muscle, what is the arm muscle name, what is the name of your back muscle, okay? So it is good to know what is a quadricep, what is a gluteus maximus, what is a bicep brachii, okay? So again, and this is the, also I think this is in your book in a little box. Muscles always work in groups, that is what I just said, okay? So they never work alone. And muscles only pull on a bone, they never push, okay? And do not mix this up with, but it's a push and pull exercise. No. Even if you do a push and a pull exercise, internally, it's still, the muscle only pulls a bone. When the muscle contracts, when the muscle shortens, it pulls on a bone. And that is how you can do a movement, okay? I always take the bicep as an example because that's an easy example, okay? So let's say when you do have a muscle contraction, what happens is, this is your bicep, this is your origin, this is the insertion. So your muscle shortens and it pulls, let's say, your forearm up. It pulls a bone, okay? It doesn't push. Even if you do this, let's say when you do a push exercise, this is a push exercise, right? And let's say if you're doing a bench press, it's a push exercise. But internally, the contraction, it still pulls the bone towards you. Do you understand that? So don't mix this up, okay? Does it make sense? But you will see that when we're doing when we do the exercises together in the gym next week. So when we're doing the practical, everything makes sense. But I want to know whether you understand what I want to point out, okay? So you have different types of muscle contractions. This is also the same as in your book. And the first one is called isotonic muscle contraction. So this one is you have a movement, okay? So as you can see, as the guy does a bicep barbell curl, okay, you have two phases. One is the shortening of the muscle, which is called concentric phase or concentric muscle contraction. And the downwards phase is the eccentric muscle contraction. It's not the relaxation phase, okay? So you do have the isotonic muscle contraction is concentric, eccentric, concentric, eccentric. Muscle shortens, muscle lengthens, muscle shortens, muscle lengthens, okay? That is the first type of muscle contraction. The second one is an isometric muscle contraction. So that means when you're doing a plank, you are holding, your muscle is contracting, but there is no movement, okay? So this is called isometric muscle contraction. It's also called static, okay? So for example, when you do a plank or when you do a wall squat, that is also some isometric muscle contraction. That one is called isometric muscle contraction. The muscle stays in one length. It is shorter, of course, because it contracts, but it is not like here, where it's always short, long, short, long, short, long. So basically, if you would hold the bicep like this, and it would always stay, it would be an isometric muscle contraction, okay? Then the last one is an isokinetic muscle contraction. This is the application of force as a constant speed, and it is the most, let's say, suitable form when you need to do rehab, because it's the fastest way you can actually develop muscle, okay? There are also gyms, they have special equipment, special isokinetic equipment, but they are extremely expensive. Okay, so what it means, it is actually kind of like always controlling the, there's always a force when you're doing your concentric and also your eccentric muscle contraction. Okay. So for example, also when you go to the pool and do an aqua aerobic class, you always have resistance, right? When you are in the water, let's say until here, and you're doing, let's say, an abduction, when you're doing a side raise, let's say you're having aqua, you know, like aqua dumbbells, okay? And you are in the water until here. So you are submerged in the water and you do this, there is resistance here. And it is resistance also when you bring your arm back again, right? So no matter where you are, there's always resistance, okay? So that's why when you do aqua, even though you don't feel there is a lot of resistance, like in a gym, because you're only weighing 10% of your body weight in the water, right? There is a lot of going on internally because you do have always resistance because the water has a resistance and it depends on how cold or warm the water is, it's more or less resistant. But this is, for example, also one kind of an isokinetic muscle contraction. That's also one of the reasons why aqua is so popular when you do rehab. Okay. But for the gym, normally, let's say when you are in a gym and you have, wait, I take my bicep, I take my barbell. Okay. So when I have here my dumbbell, and I can't see myself, wait, I need to open my camera that I can see. Okay. So when I do this, the application of force. So here I feel resistance, I feel resistance, I feel resistance, I feel here, you know, the resistance changes because the angle changes. Yeah. So let's say when I'm starting here, from here to here, it's hard, getting hard, but then the higher I get, the easier the exercise becomes, right? This is physics, right? That is what we learned in school. Yeah, so you have a resistance, your force is here, right? And then when you go down, you don't go down with the gravity. If you go down with the gravity, there's no resistance in your muscle. So you're doing a concentric muscle contraction, you're doing an eccentric muscle contraction, okay? So here, the resistance in the exercise, during the exercise will change because you have air. Okay, and you do have a free weight. It's again different when you're using a cable, for example. Okay, so if you would take a tension meter and measure the tension in your muscle, the tension will change during the exercise. Yeah, because it changes, the resistance changes. Okay, so but if you are, let's say, in the water, when you are until here in the water, throughout the whole movement, there's always the same resistance because the water has here the same resistance as here or here or here, right? Does it make sense? Yeah, okay. So again, so isokinetic muscle contraction usually is not applicable for personal trainers because it's more done in a gym. In a physio, okay? But I mean, if you hear something like that, or maybe your client will ask you, what is it? You need to know what it is, right? Okay, good. So you have isotonic, which is concentric, eccentric, concentric, eccentric. You have the static one, which is called isometric, and you have this isokinetic muscle contraction. And I have a video again for you.
In order to produce movement, our muscles contract and must either shorten, lengthen, or remain the same length. Muscle contractions can be divided into 3 categories: isotonic, isometric, and isokinetic. Isotonic contractions occur when a muscle changes length whilst contracting. There are 2 types of isotonic contractions: isotonic concentric and isotonic eccentric. Isotonic concentric contractions occur when a muscle shortens under tension. An example of this would be during the upwards phase of the squat. The quadriceps muscle group, working as the agonist, contract and shorten under tension, causing extension at the knee. Isotonic eccentric contractions occur when a muscle lengthens under tension. This occurs during the lowering phase of movements or when landing from a jump. Here, muscles act as a brake and counteract the force of gravity. During the lowering phase of a squat, the quadriceps muscle contracts eccentrically. It is lengthening, but still contracting at the same time. Isometric contractions occur when a muscle contracts without lengthening or shortening. This is a static contraction. When holding a ski sit, the quadriceps muscle group will be contracting to hold this position without lengthening or shortening. Isokinetic contractions occur when a muscle changes length during the contraction and produce
Sorry, I had to leave, let him in just a second.
movements of a constant speed. An example of an isokinetic contraction would be whilst cycling on a stationary bike that results in a constant leg movement. The resistance of the bike may vary, but the revolutions per minute would remain constant. Learn more at teachpe.com and don't forget to like and share.
Okay, so again, yeah, so this one is our muscle contraction. So we have the isometric, isotonic, and isokinetic muscle contraction. Okay, so again, let's go back to our origin and insertion. So let's say this is a tendon. I just got a rubber band, which I found. Okay, so let's say for my bicep, because it's quite easy. Let's say my bicep, the one tendon, you have a muscle, and on each side is a tendon. Okay, so on one side the tendon is attached, let's say here somewhere, let's say on the bone on your scapula and on your shoulder somewhere. Okay, we will talk about where it is. You will see that all together. Okay, let's say this one is one tendon which is attached here, and the other end from the bicep would be attached somewhere in your forearm. Okay, so this is a long tendon, just ignore that. Okay, all right, so let's say the tendon would be here somewhere. Okay, so when you do, this one would be your origin. This is the part where the tendon is attached to the bone, which doesn't do the movement. This one doesn't do the movement, okay? When you do a bicep curl. So this one would be your insertion. This is the movable part. So when your muscle contracts, so when your muscle gets shorter, this end will pull this arm up, okay? So this is what happens. Your insertion is the one which actually pulls the other end of the bone to the movement. Okay, so that is origin and insertion. Okay, does it make sense? Okay, so now we go on into how it actually works. So, and it's not necessarily a question in your exam, might be, but if there are asked question in the exam for the how everything works, it will be very simplified. Okay, I'm going to show you how the mechanism works within your muscle cell, because it's pretty cool. Okay, so when this one is a muscle, if this is a muscle and you take out the muscle fiber, okay, so let's say muscle fiber, if you have a tin or a can of sausages, okay, you have a tin of sausages and all the sausages come out, so you take out one of the sausage, that would be a muscle fiber, okay, and that muscle fiber is again has different kind of layers inside, okay, and these layers are called myofibrils. So it's one big sausage and there's a small sausage here, okay? So this one is the myofibril, and then you do have something called sarcoplasmic reticulum. That's this little dots here. And the main work or the main function of this thing here is it stores calcium. Remember, we talked about calcium yesterday. It's very important. Okay, so calcium is stored in the sarcoplasmic reticulum, in the walls there, deep inside the muscle tissue. Okay, so the myofibril is a segment, and when you see here, there is a zigzag line. Can you see that? Zigzag here, and there's also a zigzag here. Okay, and this part, there is in the middle, there's also something. Can you see that? So you have a zigzag here, and then in the middle, there is something a little bit darker. There are also two lines. Okay, so this part is called sarcomere. And let's say the sarcomere is the basic unit of the muscle. And this one, there contain subunits of protein. And these proteins are called myosin and actin. And these guys, they will glide over each other when a muscle contracts. Yeah, because I said when a muscle shortens and lengthens, the myosin and the actin, what they do is they will glide over each other. So once they're gliding over each other, the muscle contracts, and when they go out again, then the muscle relaxes. Okay, so this is basically very simplified, the sliding filament principle. Okay, so we are going now to the next slide, which is also in a book. We will take a close-up look for a sarcomere, and it looks like this. It's the same as in your book. I think it looks a little bit different in your book. I think it's a different color, and I'm not sure if there is the A band. Okay, so remember I talked about the zigzag line. So this is basically your zigzag line, what I just said, zigzag, zigzag, zigzag. And this two other lines, what you saw in that segment, it's this part, and this part. Okay, so don't worry, you don't need to know this one for your exam. I'm just explaining to you how it works. Okay, so that you can impress your client when you want to explain it to them. So when muscle contracts, the two proteins, myosin and actin, myosin is the thick filament here, the blue one, and the actin, which is the thin filament, which is the red one here, they need to connect somehow in order that they can do a movement. Okay, right? So they will cross bridge, and then they will actually do they will glide over each other. Okay, and how does it work? This is now not in your book. I'm just giving you more understanding. This is your thick one. This is the myosin. This is the one you saw with the little spikes. Okay, so in order for a muscle to contract, this myosin needs to connect somehow with the actin. Okay, but it is not so easy. So what it does is it needs to have access to the actin, but the actin is surrounded by, let's say, it's like a bicycle chain. Okay, so it's actually there is a protection around this actin. So the myosin cannot just go and hook on it. All right. So, and this chain is called tropomyosin, and there is a lock on the chain, and that one is called troponin. And in order to open this lock, because you need to get rid of this chain so that this myosin, this thingy here, can basically hook into the actin to do a power stroke, which is the contraction. Okay, you need a key for this to open it. And guess what is the key? The key is calcium. That is where the calcium comes into play. Calcium will be released and opens this lock. So this chain will fall apart. And then the myosin can actually hook into that actin, and then they can basically do a contraction. That is basically how it works. So it's very, very simplified. And again, there is another mechanism as well. So basically how it works is you do have this, it's open, but you need, so calcium opened the chain, Then you need ATP. So ATP releases some energy. It becomes ADP, which is adenosine diphosphate. So tri means 3. It's 3 molecules. It releases 1 molecule. And when it releases 1 molecule, what it can do is it can actually bind and it can do a power stroke. All right. And then the same thing happens again. So here ATP comes in, releases 1 molecule, and it gets rid again, and everything goes back. Boom, 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 boom. So this is basically the super duper principle, like simplified the mechanism of the sliding filament principle. That's basically how our muscle works inside. So when you do this, all of that one happens in your body. It's amazing. I think it's really, really cool. However, this is not for your exam, but it is good to know how it actually works. Okay. Okay, and there's one more video and then we continue.
Sliding filament theory is the mechanism by which muscles are thought to contract at a cellular level. An understanding of the structure of skeletal muscle is useful when learning how sliding filament theory works. Each muscle is made up of a number of bundles of muscle fibers. Each bundle of muscle fibers contains anywhere from 10 and 100 individual fibers. Each muscle fiber itself contains cylindrical organelles known as myofibrils, which themselves are bundles of proteins called actin and myosin. Surrounding the myofibril, there is a network of tubules and channels called the sarcoplasmic reticulum, where calcium is stored. Each myofibril can be broken down into functional repeating segments called sarcomeres. If we look at a two-dimensional model of a sarcomere, it consists of actin and myosin. When a nerve impulse arrives at the muscle, it causes a release of a chemical called acetylcholine. The presence of acetylcholine causes depolarization, enabling calcium to be released from the sarcoplasmic reticulum. The calcium binds to troponin, changing its shape and so moving tropomyosin from the active site of the actin. The myosin filaments can now attach to the actin, forming a cross bridge. The breakdown of ATP releases energy, which enables the myosin to pull the actin filaments inwards, contracting the muscle. This occurs along the entire length of every myofibril in the muscle cell. When an ATP molecule binds to the myosin head, the myosin detaches from the actin and the cross bridge is broken. When the ATP is then broken down, the myosin head can again attach to an actin binding site further along the actin filament and repeat the process.
He's always kicked out. Sorry, I needed to let him in again.
This repeated pulling of the actin over the myosin is often known as the ratchet mechanism. This process of muscular contraction can last for as long as there are adequate ATP and Ca+ stores. Once the nerve impulse stops, the Ca+ is pumped back to the sarcoplasmic reticulum and the actin returns to its resting position, causing the muscle to lengthen and relax.
Okay, so Camille is here again. Sorry, you came into the chat and then you left again, right?
Yes, because I joined my laptop now, using my laptop.
Okay. Sorry.
Because I came back from work later a bit, so I don't have time. I joined laptop now. I joined my mobile.
No problem. I recorded, and then everything what you missed, you can just review. Don't worry about it. Okay. We didn't do much, so it's okay. Okay. So is everything clear now? Can we continue? All right. So now we need to talk about the different kinds of muscle fibers in our body, because you may be wondering why some people look like Arnold Schwarzenegger and some people look very thin and slender, okay? Because that is the reason we have different muscle fibers in our body. And it depends on what exercise you do. Let's say if you go more for endurance, or if you go more for, heavy weight training, you will recruit different muscle fibers. And if you recruit different muscle fibers, some muscle fibers tend to hypertrophy, which means they will bulk up, and some that don't. That's why, for example, when you see a marathon runner, they are actually more slender because they're most likely using more different muscle fibers which don't hypertrophy. Okay, so when you do more, let's say, aerobic exercises, so you're using different muscle fibers than if you're using anaerobic exercises. When you compare a sprinter with a marathon runner, the sprinters are more chunky, right? Because they're using the muscle fibers to do explosive movements, and these muscle fibers tend to hypertrophy. Okay, so let's just have a quick look. So in your book, it looks like this. Yeah, so you do have slow oxidative, fast oxidative, and fast glycolytic muscle fibers. Okay, but we will go through this. This one is the same. This is how it looks in a book, and I'm going to explain now what it means. So as I mentioned before, we have muscle fiber type 1 is called slow twitch muscle fibers, and we have type 2A and 2B, which are called fast twitch muscle fibers. Okay, and again, it depends on what type of exercise you're using. Mainly, of course, we always using a mix of all. Okay, but you will have a certain, muscle or a certain look. Let's say like that. Okay, so let's talk about the slow twitch muscle fiber. So again, if you would go and take a look under the microscope, when you take this muscle fiber and put it under the microscope, it looks darker or more red in color. And that one is because it has more myoglobin. Myoglobin is the same as hemoglobin in your blood, but myoglobin is the red color in your blood, which is only in your muscle fibers. Okay, in your muscle it's myoglobin, in your blood is hemoglobin. And because it's used more for aerobic exercise. Okay, so it's called slow oxidative. So basically what it does, it's more for aerobic metabolism. You're using more of the slow twitch muscle fibers. And remember, we talked about the energy system. What happens when you're using your slow twitch, or when you're taking your aerobic metabolism, you're using aerobic, you're using air. When you have air, you have oxygen. And what transports oxygen? It's blood. And blood is red. And red is darker in color than white, correct? So when you are looking at a muscle fiber from a slow twitch muscle fiber, it looks darker than a fast twitch muscle fiber. Okay, so again, these are the characteristics of this. It's a little bit darker or red in color. This is because of the myoglobin, what I just mentioned. They are a little bit smaller and they don't contract fast, so that's why they're more suitable for aerobic exercises. And they usually don't tend to hypertrophy. Again, when you see a marathon runner, they're not bulky. Yeah, they're more slender. All right, because they have more slow twitch muscle fibers, which are called type 1A, type 1, sorry. Then the other two is called 2A and 2B. Okay, so intermediate twitch and fast twitch. Okay. So in comparison to the slow twitch muscle fiber, they are a little bit whiter in meat, let's say like that, in color, and they are bigger in diameter than the slow twitch muscle fibers, and they are more suitable for very explosive movements, okay? So they contract faster and they are more strong, right? And these muscle fibers, they tend to hypertrophy when you overload. We will talk about hypertrophy later on, maybe tomorrow. We are not going into what is hypertrophy and how to do hypertrophy training, okay? So how can you remember the difference between slow twitch muscle fiber and fast twitch muscle fiber? Because obviously we do have mixed muscle fiber in our body. And I always remembered it. When you think you go to Kentucky Fried Chicken and you buy a chicken wing or a no, not a chicken wing. Let's talk about chicken breast. Chicken breast and a thigh, okay? How does the meat look like? The breast is much lighter in color, correct? Yeah. And why is that? Because the chicken, when it needs to fly, yeah, so let's say the chicken is standing around and suddenly the dog is coming and chasing it. The chicken needs to go very strongly up and disappear. So it has the chicken meat on the breast has more fast twitch muscle fiber, because when the wings go up and down, it contracts very fast and it's more strong. And that's why this one is more fast twitch muscle fibers. That's why the meat in chicken is whiter than if you see a drumstick, because the chicken stands the whole day. It does a long, slow aerobic. So that means the chicken thigh is not contracting as fast and strong as the chicken wings and the breast. That's why when you see a drumstick is darker in meat than chicken breast, okay? So if there should be an exam question, what is the difference, or how can you see the difference between, or what is the main difference between slow twitch fiber and fast twitch muscle fiber? You just think fast twitch muscle fiber, chicken fast, okay, chicken breast is white, so fast is whiter in color, okay? So basically this is how you can remember that, okay? Does it make sense? Yes? Okay. However, when you are training, you can change your muscle fiber types with training, okay? So for example, if somebody was always a marathon runner, but now he starts going into the gym and does powerlifting, they can actually change their look. That's why when you see bodybuilders, how they're changing their physique, that's because they're changing their muscle fiber types, okay? Okay, does it make sense? Okay. So again, there's another video for you because I need to save my voice.
Within skeletal muscles, there are 3 different types of muscle fibers: Type 1, Type 2A, and Type 2B. Each fiber type has different qualities in the way they perform and how quickly they fatigue. Type 1 muscle fibers are also known as slow twitch fibers. They are red in color due to the presence of large volumes of myoglobin and mitochondria. Both of these are important for transporting oxygen in the blood. Therefore, Type 1 muscle fibers are very resistant to fatigue and are capable of repeated low-level contractions through aerobic metabolism. For this reason, the muscles containing mainly Type 1 fibers are often postural muscles, such as those in the neck and spine, due to their endurance capabilities. Also, athletes such as marathon runners have a high number of this type of fiber, partly through genetics, partly through training. Type 2A fibers are also sometimes known as fast oxidative fibers and are a hybrid of Type 1 and 2 fibers. These fibers contain a large number of mitochondria and myoglobin, hence their red color. They manufacture and split ATP at a fast rate by utilizing both aerobic and anaerobic metabolism. As a result, they produce fast, strong muscle contractions, although they are more prone to fatigue than Type 1 fibers. Resistance training can turn Type 2B fibers into Type 2A. Type 2B muscle fibers are also known as fast glycolytic fibers. They are white in color due to a low level of myoglobin and also contain few mitochondria. They produce ATP at a slow rate by anaerobic metabolism and break it down very quickly. This results in short, fast bursts of power, but with rapid fatigue. This type of muscle fiber can be turned into type 2A fibers by training. They are found in large quantities in the muscles of the arms. For more information or to test yourself with our interactive quizzes, visit teachpe.com.
Okay, I think that one was pretty much the same. What
Simon,
yes?
for the slow twitch muscle fibers, do they grow? How do they grow? Because the fast twitch muscle fibers grow in size, right? So do slow twitch muscle fibers grow in size, or they grow by being more resistant to fatigue?
Yes, they don't tend to hypertrophy, they don't grow. Then yeah. So the fast twitch muscle fibers, they are the ones who are when you do hypertrophy training or when you do strength training, there will be the one who are recruited. Yes. So slow twitch muscle fiber, that don't, of course, there is a little bit hypertrophy. I mean, even though if you do a very lightweight, you know, when you do endurance, of course, you will have a certain hypertrophy. You always have a hypertrophy, even though if you're doing, let's say 25 or 30 reps or 50 reps, there's always a muscle grow. Okay. But it depends on when it starts. So it is, we always have a mix in our body. Okay. It's not only the same as if we are usually when we are doing training or when you're doing, remember yesterday we talked about our energy system. When you have a tennis game, yeah, so you always change between aerobic and anaerobic energy system, or when you play soccer, yeah. So it is possible, if it is really, really boring, that actually you're just kind of like standing around, depends on what, you know, position you have, and you're just using your aerobic system. But if it is really, really a hard game where you really have to just go forth and back and forth and back, and then, you know, you will use, maybe that day, you may use a little bit more of the anaerobic pathway. And the thing is that muscle fibers, the slow twitch muscle fibers, they are using the aerobic energy system, okay, and fast twitch muscle fiber using the anaerobic energy system. Okay, so anaerobic, you will build muscle. That one is the muscle which you actually recruit when it comes to hypertrophy training. So hypertrophy is when your muscle grows, so your muscle fibers, they're growing. But again, we are going into different types of muscle or hypertrophy training where we talk about programming. Okay, clear? Okay, any more questions? Can we move on? So this is the same as in your book. So
I have a question.
Yeah.
Sorry. I just want to ask you, like, you have been mentioned about type 2A and 2B, yes? So
yeah.
I just would like to ask you, there is some people, you know, like skinny guys or small guys, but they can do high weight and less reps. Like they are very strong, you know, like let's say some people like boxer or people like play Muay Thai or.
Okay, so that one is a difference. Okay.
Like,
yeah.
This
so
one, they have type 2A or type 2B more, like, which I mean, like there is a video for famous guy, his name is Anatoly, you know, very skinny guy.
Okay, so it's a difference.
But he go to gym, he challenges people. But
yeah. Okay, so there's a difference between strength training and hypertrophy training. Bodybuilders, they do hypertrophy training, okay, because they will do, they go for hypertrophy training because they want to build muscle. They want to have kind of like, you know, the nice definition, and basically they don't care how strong they are. You know what I mean? So strength training is people don't really care how their physique is. People who do powerlifting, they are just keen in, okay, they have a certain goal. Maybe they want to do a competition. They have a goal. They need to carry 200 kilos in a certain, you know, time, because they have a time frame. And their goal is they want to lift this weight, no matter, they don't really look that strong, okay, because they're training differently. They have a different training technique, and they don't of course, they have hypertrophy, but otherwise they will not. If you don't have hypertrophy, you don't have strength. You know, strength and hypertrophy also goes into one hand in hand, right? So if you're not strong, you can't lift a weight. If you can't lift a weight, you cannot do bodybuilding, right? So, but the thing is that if someone, a bodybuilder, there's a different hypertrophy, okay? But we will again talk about it when we talk about programming. A bodybuilder can look huge, but it's possible that he only looks big because the muscle or the muscle, let's say the, not the muscle fiber, but the fluid which is around the muscle fiber is bulked up, okay? But they're not strong, okay? They look strong, but they are not as strong as another guy who might look quite skinny and they are actually really, really strong. It's a different type. So there's a difference whether you do training for powerlifting, so for strength, or hypertrophy, okay? There's a difference. Yes, of course, you need to be strong and you will build muscles for hypertrophy to a certain point, but there is a difference between strength training programming and bodybuilding programming or powerlifting. It's a different training principle, it's a different program, and also it's a different technique. Yeah. So if you see, if you have a bodybuilder, right, they will probably go, let's say, for an isolation curl. They will go for isolated curl, right? Because they really want to isolate the bicep, they want to do that, okay? A power lifter would not do that. Or usually they don't do that because it's not beneficial in order for their lift, okay? Usually they're doing compound lifts in order, and they need momentum in order to lift a certain way, okay? So that's why when we're talking about lifting techniques, we will go through to the details of this. But you're right. Very often they look big, but they're actually not very big. So it's kind of like a surprise egg, you know, you never know what's inside. So anyway, yeah, it doesn't, sorry, I'm German, I have a weird humor, but you know what I mean? It's like they look very scared, but you know, like very bulky, but they're inside, they're very soft. Okay, so anyway, what happens is when you have, Sonia, stop laughing, I can see you laughing. Okay, so again, we have muscles, we know how it works, and now we need to see how it's everything connected to our brain, okay? So when it comes to nerves and muscular movements, and I think this is exactly the same in your book, and it says, a muscular movement is initiated through the stimulation of a muscle, and on a muscle, there is something called motor nerve attached, okay? So, and then there will be a feedback because it's connected to your brain and the outcome of that movement. So you do have two things connected on your muscle, which is a nerve, which is the motor nerve, which is connected to your motor unit. And we talk about the motor unit in a minute, okay? And we have a sensory nerve. Sensory nerves are these three things here below, okay? These sensory nerves, they are also called, I'm sure you have heard of them, proprioceptors. What they're doing is they keep sending to the brain signals concerning the muscles, ligaments, and tendons to the brain, okay? So there can be either on the muscle itself, in the muscle tendon, or they can be at the joint. It's kind of like a telephone wire, okay? So they are attached in the joint as receptors. They are attached in the muscles, and in the muscle itself, they're called muscle spindles. And they will report to the brain if there is any change of the, you know, length or the stretch of the muscle. And there is another thing, it's called Golgi tendon organ. And as the name says, Golgi tendon organ, that sensory nerve is located in the tendon, in the muscle tendon itself. And that one will monitor if there's any changes in the muscle tension. And why you need to know this one comes later when we're doing flexibility, and when we're talking about stretch reflexes and how you can actually use proprioceptive stretching, so PNF stretching, in order to improve, let's say, flexibility in your client. Okay, so you need to know how this one works. Okay, so number one, your muscle, you have a muscle. In your muscle there are some wires, and they come to your brain, and they will talk to each other. Okay, and there is also some nerves that there are connected. The muscle is connected not directly through the brain, but it is connected to the motor unit to the brain. Okay, and I have a picture here of a motor unit. Okay, so don't worry, you don't need to know this for your exam, but you need to know how it is. Okay, so what it is, again, you have your muscle. This one is your muscle fibers, and you do have different, they're called axons. Okay, and they are connected to your brain. Okay, so this one is all you need to know. You don't really need to know all the cross bridging and all the stuff, because that one goes far too much into exercise science. Okay, you don't need to know that. All right, as long as you know, okay, there's a connection between your brain and your muscle, it's fine. It's a motor unit. And the thing is also, what you can understand is when you do a small movement, you have less motor units which needs to be stimulated to do a movement. Yeah, so when I'm taking my mouse, that one requires much less motor units than if I would go and do a bench press, or if I would do a leg press. Yeah, so that one is basically how it works. So the greater the movement is, the more motor unit are required in order to perform this muscle. Okay, does it make sense? Okay, yes or no? Okay, so I feel that you understand that, right? So okay, I have again
The action potential that allows voluntary muscle contraction begins in the motor cortex of your brain, and it's relayed down from the brain through the spinal cord via some nerve fibers called tracts. From here, the impulse is relayed to the muscle via a peripheral nerve. Now, the peripheral nerve is made up of a series of sensory neurons and motor neurons. A motor neuron is made up of a cell body, which is in the spinal cord, and then an axon. At the end of the axon, it branches to form axon terminals, which attach to the muscle fibers and form the neuromuscular junction, at which it innervates the muscle. So
you don't need to know this for your exam. Don't worry about it.
Neuron
Okay?
made up of its axon wrapped in myelin
It's
sheath,
just
which
interesting to
increases the
see
speed
how
of
it actually
conduction,
works.
and the axon terminals, which branch onto the muscle fibers. A motor unit is the number of muscle fibers which are innervated by one motor neuron. In this case, one motor neuron is innervating 3 muscle fibers. So muscles that control precise movement have more motor units. So say the muscles in your hand or eye have about 10 to 15 muscle fibers supplied by each motor neuron. Muscles which require more gross movement have less motor units. So your biceps muscle and quadriceps muscle have about 1,000 plus fibers stimulated by a single motor neuron.
Okay,
so
let
more
me just
motor units in a muscle.
let me just kind of like stop here. I just said to you, a small movement needs less motor units, right? Because you don't need to have so much muscle working together. But he was talking about precise, let's say for your eyes, for example, okay? That is different, okay? So don't go into, don't listen to that one, because that one is different, because that one has to do with your sensory nerves in your eyes, okay? So these muscles in your eyes are different to, for example, your skeleton muscle, okay? So don't think that I said something wrong. It's just like when you have when you need to focus, let's say for something very precise, you have you have maybe less motor units. No, you have less one motor, you have more motor units, but you do have less muscle fibers attached to it, okay? So that one is different, okay? So don't get this one wrong, sorry to say again. Maybe we have to change that video, hang on, wrong. Sorry, I had to just, and you don't need to know this for your exam, okay? So you just focus on the, what he says about the, about the skeleton muscle, okay? Move. Work. Hey, why is it not working? Okay, hang on. I try one more time. If not, I need to play tomorrow.
The action potential that allows voluntary muscle contraction begins in the motor cortex of your brain, and it's relayed down from the brain through the spinal cord via some nerve fibers called tracts. From here, the impulse is relayed to the muscle via a peripheral nerve. Now, the peripheral nerve is made up of a series of sensory neurons and motor neurons. A motor neuron is made up of a cell body, which is in the spinal cord, and then an axon. At the end of the axon, it branches to form axon terminals, which attach to the muscle fibers and form the neuromuscular junction at which it innervates the muscle. So here's a more microscopic illustration of our motor neuron made up of its axon, wrapped in myelin sheath, which increases the speed of conduction, and the axon terminals, which branch onto the muscle fibers. A motor unit is the number of muscle fibers which are innervated by one motor neuron. In this case, one motor neuron is innervating 3 muscle fibers. So muscles that control precise movement have more motor units. So say the muscles in your hand or eye have about 10 to 15 muscle fibers supplied by each motor neuron. Muscles which require more gross movement have less motor units. So your biceps muscle and quadriceps muscle have about 1,000 plus fibers stimulated by a single motor neuron. So more motor units in a muscle equals more precise movements.
Okay, so is this understood, what I want to say? Questions? Okay, this one is the same as in your book, I think, or similar in your book. Okay, so again, very simplified. You have your brain, you have your central nervous system is your brain, and you do have, again, as I said, either a motor unit. Motor unit is the one which is attached to the muscle, or you have the sensory nerve. A neuron is a nerve. Neuron is nerve, okay? So for example, your eye has receptors and it sees a glass of water and it will actually recognize this and say, hey, there's a glass of water. Are we thirsty? And then the brain checks with the other, departments in our body whether we want to have this glass of water. And then what it does, oh yes, it's a good idea to have this water. So what it does, it sends via the motor units, okay, and signal to your muscle, hey, can you do a flexion? Can you actually do this movement? Do this, open your hand, close your fingers, bend again, put it to your mouth, lift your head, open your mouth, drink it, and so on and so on, okay? So this is basically how this whole thing works. And I always think that this is so amazing how our body works, and we take this for granted, and it's like so amazing how it works, okay? So this is basically how our nerves and our muscles work together. And there's another thing which is called a reflex, okay? So there is a thing called withdrawal reflex. So obviously when we see a glass of water, we want to drink it and we do this voluntary, right? But usually nobody puts a hand voluntary in a fire unless there's something not 100% right with their, mental health. So let's say if you are standing on a stove, and often when unless you have kind of like a gas, but if you have like, like the normal stove without any lights and stuff like that, sometimes you don't see that the plate is still hot and you're leaning against it. What happens when you lean against it, what happens is you do have the sensory, this time it will be in your fingers. Oh, damn, this is hot. And what it does is it pulls back. This is called the withdrawal effect. So what it does, it will actually, it's basically the same system. Yeah. So you have also your receptors on your motor unit. Yeah. So what it does is the sensors here, they will say, hey, this is very hot. That is the sensors tell the brain, hey, can you please tell the muscle department to flex the arm? Otherwise I will burn. Okay. I mean, it goes all within milliseconds. That's the beautiful thing about it, because otherwise you will burn yourself, right? So a healthy person, usually they have a reflex like that, okay? So this is called the withdrawal effect. So usually it doesn't take like very long. It's not like, oh, you know, this is hot. Can you ask the brain if this one is hot or not? Or, you know, yes, it happens quite fast. So this one is a reflex. And we can basically, and then there's another picture again. So it's exactly the same, yeah? So this one is the close up to the muscle spindles and the other sensors, yeah? So again, you have your brain, you have your motor neurons connected to the muscle, okay? So you see this one is a tendon. This is nice. You can see this one would be the origin of the muscle. This one is the origin of the muscle. And this is the insertion of the muscle, yeah? Can you see that? So it's a tendon here, and this is a tendon, and this is your muscle, okay? So you have receptors in your tendon, which is called Golgi tendon organ. That's the name. That's why it's called tendon organ, because it sits in a tendon. And you have the muscle spindles, okay? And what they do is, again, the muscle spindles, they're checking sudden changes in length, okay? And the Golgi tendon organ will sense changes in the tension, okay? And if that one is getting too much, this is I will show you in a reflex just now. I'll show you that now. Okay, I think that's easier for you. Okay, so what that happens is everyone here can see. I think this is important to see now. Everybody can see, yeah? Okay.
Yes.
Okay, good. So let's say I don't know how heavy this is, okay? And somebody stands here and will give me that weight. So let's say I do this. Can you see what my arm does? Okay, so let's say I have here a weight and I will do this. You will see what my arm does. I turn around, you can see that better. This is the weight. Did you see that? Okay, I show it again. Don't worry about my finger. Look at my arm. What did it do? What it did was, the moment I realized, oh, this is heavy, what happened? My arm first went down, right? So what happened with my muscle? My muscle length here changed, right? From here, it suddenly went down, so the muscle length changed, yes? So what happened is the muscle spindles told the brain, hey, something is wrong here. You better fire up this muscle, otherwise I drop the weight. So what it did was, okay, contract, 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 because if you don't contract, you will lose the weight, okay? So this one is a job of the muscle spindles. Now, this is the interesting part now. When my muscle contracts, and this is a static muscle contractions, okay? So I will hold it here, muscle spindle kick in, tell the bicep to fire up. Okay, my muscle is firing up. Ooh, fire up, I can feel that. So what happened with my muscle? Is it short? Is it contracted? Is there a lot of tension or not?
Yes.
There's a lot of tension. That means my muscle is short here. And look at the picture. When my muscle is short, the muscle tendon is longer also, right? Because that one is under tension, right? So what it does is the Golgi tendon organ kicks in after a few seconds and will check on the tension here, right? So it will check on the tension on the muscle. So first, muscle spindles do their job. Tell the bicep, okay, fire up, because if you don't fire up, we will drop the weight. After that job is done, the Golgi tendon organ checks on the tension. And it will tell the brain, okay, it's okay. So this one is 5 pounds, it's 2.5 kilos. So I can hold it maybe for a minute, right? But this one is the tension. It's tension, tension, tension. How long? So after that, let's say after 3-4 minutes, what will happen? I finally have no choice but to let go, right? Because this is a safety mechanism of our body. The Golgi tendon organ measures the tension of that muscle. And what it tells says, hey, this is getting heavy. This one is really getting heavy. So maybe can you please tell the brain to contract the opposite muscle so that this one can relax. Remember, we talked about the agonist is the bicep now. And the tricep is relaxed, right? Because you cannot contract this muscle and this muscle. It doesn't work the way, right? So this one is now, blah, 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 it's kind of like loose, yeah? So this one is contracted. This one is relaxed. So I do this for a while until I'm getting really fatigued, until my brain gives the information, okay, guys, here, contract the opposite muscle so that this muscle can relax, and then you let go. So this one is called, this one we will talk again about this mechanism when we're talking about the flexibility, yeah? But that one is also, let's say, if you're going to the supermarket and your car park is very far away and you are holding very heavy weights, you walk and walk and walk and walk and walk, and then maybe it happens you need to, after a while, you have to just drop the weights or do this, and then you lift up again, and then you go. That is exactly what happens here. So your Golgi tendon organ is always measuring the tension of your muscle and giving this information to the brain whether everything is fine. Because if that wouldn't work, what would happen with your muscle? It would rupture and eventually it would tear, right? Eventually, most likely it will injure themselves or it will tear because the tension is too much. And if you still go on, it would tear, okay? Or at least it would kind of like, get small tears, okay? So this one is your connection with your sensory neurons or nerves, connection with the muscle, okay? And this is important that we talk about this one today because you need this later when we're doing stretching, when we're doing partner stretching and we're talking about flexibility training, okay? But I feel this is actually a very interesting, it's actually very interesting. So there is another thing. Oh yeah, okay, so this is the same thing, blah, 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 okay. Same, yeah, okay, so you have the muscle spindles and you have the Golgi tendon organ. So this is in your book, but it is not this picture. It's only one page in your book. So please make notes or take a screenshot of this one or whatever, or Google it, or yeah, but this is exactly what this page means, okay? Another thing is also, you've seen this one. When you have a injury, or if you have a baby just born, they're doing some reflex checks. Yeah, so where they're doing basically the patella, what they do is they will stimulate the patella tendon. They will basically tick on this one. So if that one is ticked, so that your muscle contracts and then your leg goes up, okay? You've seen this, right? That the doctors do that, okay? So it's called the inverse stretch reflex, but we will talk about this one when we, again, in details again. We will repeat it again when we talk about flexibility training again, but you need to know it now, because when we talk about it in next week, when we do the practical, you need to know this, okay? So we have a 5 minutes break, but I give you a 5 minutes break, and then we start with the muscle and joint in action. Okay, 5 minutes break, okay?
Yeah, okay.
Okay, I just redo this.
The action of a single muscle can be
Stop. Okay. Okay, everyone ready again? Let me know if you have any questions, okay? Okay, let me know when everybody is ready again.
I'm ready.
Okay. All right, so there is a video which explains again agonist, antagonists, synergists, and fixators. Yeah, so please have a look. Not now. Play.
The action of a single muscle can be described pretty simply. A muscle is connected to two or more bones by tendons. As the muscle contracts or shortens, it pulls on the tendons which move the bones in relation to one another. In reality, movement is much more complex. Several muscles work together in unison to create a desired movement. They each have different roles in different movements.
Oops, sorry. I just wanted to turn on my camera. Ah.
Let's look at a common exercise, the bench press, and identify the roles of different muscles involved. The primary muscle providing the force behind the movement is known as the agonist. During a bench press, the agonist is the pectoralis major. If you look at where the pectoralis major attaches to bones, its origin and insertion, and the direction of its fibers, you get some idea as to what its function will be. As it contracts, it pulls the arm toward the center of the chest, flexing, adducting, and internally rotating the humerus. This is the main movement behind a bench press. But the pectoralis major has help from other muscles. Synergy is when two or more things work together to accomplish something greater than what they could do alone. The muscles that don't provide the primary force behind the movement but assist the agonist are known as the synergists. One of the synergists in the bench press is the triceps brachii. Once again, when we look at the origin and insertion of the muscle, we can get a pretty good idea of its function. The triceps extends the elbow. Another synergist, the anterior head of the deltoid muscle, helps to flex and internally rotate the shoulder.
Yeah, so this one
Stabilizing muscles help to prevent unwanted motion at a joint. During a bench press, the pectoralis major, the anterior deltoid, and the triceps work together to pull the humerus toward the chest and straighten the arm. A group of muscles known collectively as the rotator cuff surround the head of the humerus and help to pull it into the socket, stabilizing the shoulder joint during the forceful movement of the arms and chest during the bench press. While these stabilizing muscles may not contribute much to the force lifting the barbell, they play an important role in movement by preventing the humeral head from slipping out of its socket. Muscles that would create a movement opposite that of our desired movement are known as antagonists. If our agonist pulls the arms toward the chest, our antagonists pull the arm toward the back. Our antagonists, while performing a bench press, include the latissimus dorsi and the posterior head of the deltoid. The antagonists allow themselves to relax and stretch in length to accommodate the opposing contraction. This is called reciprocal inhibition. It may be tempting to draw the conclusion that the agonists are active while the barbell is being pushed up, and the antagonists are active while the barbell is coming down. This is not the case, however. The agonist and its synergists continue to work to slow the descent of the barbell. If the agonists were to relax and the antagonists to contract during a bench press, there would be no force slowing the barbell, and the combined force of gravity and the antagonists would pull the barbell rapidly and violently into the chest. While the agonist and synergists are creating enough force to overcome the weight of the barbell, they shorten and push the weight up. This is known as a concentric contraction. As the agonists and synergists relax enough to allow the weight to come down, they lengthen but are still working to prevent the weight from falling too quickly. This is known as an eccentric contraction.
Okay. All right, so it's the same. Okay, let's move on. Again, agonist is the prime mover, antagonist is the opponent. The connection muscle to bone is tendons, ligaments connect bone to bone. The origin of the muscle is the fixed point. The insertion is the other end of the muscle, which moves the, let's say, the bone. And then the synergist is the helper muscle, and the fixator muscles are these stabilizers, okay? So again, there is a picture here. So this one would be, is your bone, the origin of, let's say, this is your bicep brachii. That's the name of the muscle. This one would be your origin, and this would be the insertion, okay? And these are the tendons, okay? Okay, so no panic. This is exactly the same what is in your book, okay? But I do have actually one thing which I want to share with you. It's just a suggestion, and it helps a lot in order to understand the muscle, how they're working, okay? Just a second, who is this? Okay, never mind, it's okay. So no, some has to leave. Okay, good. Up to you. Okay, so this is your muscles. They are all in your book, okay? So, and the origin is O here, and the insertion is I, okay? So when you don't know in your book what it means the origin and the insertion, okay? So what we have is we go through the muscles, and we're going through also the how they work. Okay, so I have really good examples of it, demonstrations, and you can just make notes. But this is what you have in your book, but you do not need to do this. You don't have to have this for your exam. There would not be a question when you do the exam in Germany. They would ask you, okay, what is the origin? What is the insertion of, you know, the long head of the tricep and the, you know, the lateral head and the medial head of your tricep. So we don't do that. All right. For us, it's more important that we concentrate on lifting techniques and that you know all the other stuff. Okay. But in Germany, I had to know every single thing. And what but of course, you need to know the name of the muscles, where they are. So when we ask, where's your bicep? And you say it's here, that's not really clever. Okay. So you need to know roughly where your muscle is. Okay. And also what muscle groups are working together, because that is important when you are programming your client. Okay. The thing is also that I do have something called, it's called muscle catalog. It is like for children, it's like a drawing book. And what I do is it's voluntary. It's just for you. If you want it, you can use it. If not, it's not for your exam. It's just for you. Very easy to remember. And I will show you afterwards, or maybe tomorrow, how it looks like. Yeah. So it will be kind of like, hello.
Yeah, sorry. I say I want it.
Yeah. Okay. Yeah. So it's I will share it with you in a group so you can print it out. And what I would suggest is or maybe I can show you just a second. What I do is I will just show you, hang on. I show you afterwards how it looks like because it's in the studio. I don't have it here. Basically what it is, it's like the muscle and it shows the bones. And I would suggest you take two colors, one maybe for origin and one is for insertion. And then what you do is you just check out, okay, where is your origin? Okay, and you color it. Okay, the origin is here and the insertion is here. So when you do that, particularly when we get a little bit older, because Danielle, you are the youngest, so for you it's not so important. You will learn this by heart very easy. But the elderly generations, okay, they might want to do that. It's just like, you know, it's easy to understand. It's very helpful. But again, this is not official FISAF material. I just did it when I studied myself, the muscles, which is like a long time ago, but it helped me a lot. Okay, so we don't go through all of this one. We don't do this one. We go through, but not like one by one, because that one is too difficult to understand. But what you do is now I have extracted, this one is exactly the same as in your book. Yes. So you take your book and you can make notes because you will see that here. And I will go through with you. Where's your origin? You can see this one. It says here, the origin would be the coracoid process, which is like a hook-like structure. It's this. This is your origin here. And the other head is going to the scapula. Okay, so here you see it again. One part, because bicep is two. It has two heads, as you can see. It's one muscle, but it will split here. And one part is attached to this thing here. It's called coracoid process. And the other one is attached on your scapula, which is your shoulder blade, okay? And then the insertion is your radius. Remember, we talked about the two different bones in your arms, okay? So this one is how it works. We go one by one. We see how many muscles we can go through. But it's actually very interesting that you will see what it does. And then it's also the joints involved. So you will see some muscles have more than one joint involved. Yeah. So this one, the main, yes, it is also because it goes over your shoulder blade, but the main action happens in your elbow. Okay. So it does an elbow flexion, which is this. And it does a forearm supination. That's why, remember, we talked about supination yesterday, and pronation, supination. So when you do a bicep curl, you're doing a supination and you're doing a flexion. Okay, and that is your bicep. So you know now, okay, this is basically what your bicep does. Okay, mainly. Of course, it do also different movements because we say they're always working group, but that you get the basic idea of it. And then what I have here, there's a little video here. I will click on it and you see how it actually works. You see that? 1, 2. Yeah, so this is basically the movement. 1, 2. Okay. Everyone is happy with this? Can we go through? I think that's much, much easier to understand than when we just go, book like this. I think this is easier to understand. Yes?
Yes.
Okay. All right. So now you learned already the first muscle, which is your bicep. Bicep has two heads. And that's why it's called bi, because two heads. It has a long head and a short head. One is attached to this little hook-like structure. It's called coracoid process. And the long head is attached to your scapula. Okay. And its origin is here. It's on one of the forearm bones, which is called radius. And it does a supination and a flexion. Good. Next one. If I'm going too fast, stop me. Okay, just shout. Now, this muscle is actually a muscle which is a synergist to your biceps. Synergist is a helper muscle. Okay, that one is called brachialis. So usually you cannot really isolate the muscle. When you train this muscle, it is always involved with your biceps. You can't isolate your brachialis. You cannot say you only train this one. Not really. Okay. So you can see this guy has only one attachment. So the origin is your humerus here. And it also goes to your ulna. It doesn't go to your radius. It attaches to a different bone in your forearm. Okay. And this is a very strong elbow flexor. Okay. So you see, when you do a bicep curl, it's not only your bicep is making the move. It is obviously also your brachialis. But I'm sure you hardly go to the gym and say, oh, today is brachialis day. Yes, I will train this fella very hard. Yeah. So usually you don't do that. Normally it's arms, it's biceps. Okay. So again, origin is your humerus. Now you know why you need to know the names of the bones. Okay. Humerus is your arm, the bone of your arm, and then it will be attached to your ulna. And what it does is it does also an elbow flexion, but it doesn't do an supination. It does actually the opposite. It does a pronation. Okay. And I show you how it looks like. Please have a look here. Okay. So when you do reverse curls, you are working a bit more your brachialis. Okay. Next one. I go next when I don't hear any comments.
Simone,
Yes.
when you're doing bicep curl, right?
Yeah.
Is because your forearm, if your forearm relaxes, the weight will drop this way, right?
Sorry, again?
Like if you're holding the weight, it has to be, is it considered forearm flexion to maintain it neutral?
No, you're doing a supination and you're doing this. That is what your bicep does. Your bicep does a supination, or as we call it, a rotation. Remember, supination, and it does this. When you do this, like with a pronation, of course, your bicep is also doing the work, but the brachialis is doing the main work for that. So the bicep is the main muscle when you do it this way. When you do it that way, your main muscle would be your brachialis and your bicep will become the helper.
But when you're trying to hold a heavy weight, right? You have to keep your wrist neutral in relation to your forearm.
Yes.
So is this considered, because you're holding it like that, holding the weight like that? So is it considered flexion? Because
what is considered flexion? This one is a flexion. This is a flexion. What do you mean? What do you mean is okay. What do you mean with flexion?
Meaning like example, if I hold a heavy weight like that, right?
Yeah.
If I just completely relax my elbow, my forearm, then the weight is just gonna bend my wrist like that. So,
you don't bend your wrist. You mean your wrist? You're holding it statically, so you don't do a movement. You don't do a movement. You do this.
Oh, so it's not considered flexion when you hold it.
When you hold it, well, the thing is, from here, it's a flexion. Now you just hold it in a flexed position.
Oh, okay, can.
This one is an extended position. When you hold it like this, it's a flexed. When the angle is short, it's a flexion. When the angle is long, it's an extension.
Okay, thank you.
Okay. Never mind. If you have more questions, write it down and ask. No problem.
I don't know. I think he has been mentioned about maybe forearms, because the way of the movement that he bows now look like he hit his forearm. Yes, not his hit his biceps.
Yeah, like
he opened his hand. That's why he opened his hand. Why you open your hand? I mean, this is the question. Like you need to keep your hand closed, and as Simone say, flexion. Yes. So why you open your hands? Mean you hit your forearms? No, Simone. You see,
I
straight
can't
his
see
hand.
you. Can you open your camera that I can see you, Camille? Otherwise, it's difficult. So what do you
Yeah.
mean? Can you show me what you mean?
No, he did something like this, yes, like biceps, but at the end he do his hand like this.
Yeah, I don't know why. Daniel, why did
how you can play
why did
Like,
you
like why you open your hand when you do biceps? Why you
Yeah,
should
so-
be your hand like this?
Yeah, so your hand should be like this. But when your hand is like this, is it considered flexion because you're trying to hold the weight up? Because if you're
let's see. When you do this, remember we talk about this one is an extension, this is a flexion. But usually you don't do a bicep curl like that, right? So we're talking about the bicep. The bicep is here. It's a flexion in your elbow. And when you do this, it's also a flexion of the elbow. You don't do something like that, right?
but
Unless
if it's neutral, what is it considered?
you mean your wrist.
Yeah.
Your wrist is pronated. This
Oh,
is
pronated.
semi-pronated. This is supinated. This is semi-pronated. This is fully pronated. You can say
Okay.
yes, you can say it's neutral, but neutral means neutral is neutral. Neutral is like this, right? So let's say if you're reading a program, okay, and you say, okay, bicep, let's say semi-pronated. Everybody knows semi is half pronated, is this. When you do a hammer curl, that's a semi-pronation. Hammer curl, you're working more your forearm, you're doing semi-pronation. Yes or no? Yeah, makes sense?
Yeah, but I shocked because he mentioned about wrist. Like, why I need to open my wrist like this when I do biceps? I need to be like this. It's not like this. That's why maybe he mentioned forearm.
I'm not too sure. I'm not too sure. But what we can do is, can you write it down? And when we meet next week when you come to KL, Daniel, you show me what you want to know. Okay, please remember us, because then we go through with you together. Okay. All right, cool. All right, so let's go on. There is another thing called brachioradialis. So you see, you have a lot of muscle involved when you're doing a bicep curl. You have your bicep brachii, you have your brachialis, and you have your brachioradialis. Okay. So, and as you can see here, its origin is also on your humerus, but much lower. You see that? So, but it goes also over your elbow joint. And when it goes over your elbow joint, it does a flexion as well. But it does here a flexion. It assisted either in a semi or full pronation or also in a supination. Okay. So no matter how you basically change your hand position, basically that one is always involved, more or less. Okay, so let's say when you're doing a hammer curl, of course, it's not only the radiobrachialis working, but when you do this and you touch that muscle, it's not as much under tension as if you turn it, or if you're doing a full reverse curl. Yeah. So when you're not 100% sure, what you do is you try it out, take a weight and see, okay, I'm changing now my hand position. Where is it actually more? Where's the tension more? Yeah. So just in case, if you don't know when you program, okay, do I need to change something like that? But normally, when you're doing a bicep curl, for example, because bicep is a small muscle, and unless you go into bodybuilding and you want to have like all this little muscle also involved, usually when you do a bicep curl, you do different variation with bicep curl, you're fine, because the thing is a small muscle and you do it as a supplementary exercise as well. because the bicep is always involved with a lot of other muscles as well. And not many people have time to spend a lot of time in the gym, okay? So we go through this one that you know what is the purpose, what is the work, why is the muscle there, okay? And the exercises we do all when we do together the practical, okay? So what we are discussing now here is what does the muscle do? What is its purpose, okay? And here are only examples of exercises. Examples. We are not going to talk all the exercises. The exercise is practical. We do next week when we meet. Okay. All right. So let's see here what it does. So I'm going to click again. You see, it's just like a flexion again in your elbow, but the hand position is different. Okay. So let's see on the left, on the right side. And this one is again, it goes from an supination into the pronation. Okay. Do you need to see again, or can we move on? Move on. Okay. Let's go. Okay. So now let's do the opposite side. The opposite is your tricep. Triceps, three muscles, three heads, as the name says. Okay. Again, this is not your exam, but you need to know how it is, how it looks like. Okay. So as you can see, the long head, and the long head is a long one, and that one is attached to your scapula, just a little bit here on that side. Can you see that? All right. And then the both the medial and the lateral head, they go on your arm. Yeah. So only the long head is attached to your shoulder plate. And the other two heads, they are attached somewhere on your bone in your arm, on your humerus. All right. But all three insertion is in your ulna. So also in your forearm bone. Okay. But all three do an extension of your elbow. Okay. And that one looks like this. That's its main function. We could argue now, because the long head is attached to your shoulder, of course, it will assist when you do, let's say, anything what your posterior deltoid does. The long head of your tricep also would be involved, because if it is attached to the shoulder blade, it will help the other muscle doing some exercises. But the main function of this muscle is an extension in your elbow. Okay? Make sense? Like that, or like that. It's an extension. It stretches out the elbow. Okay? Make sense? Okay, next one. Now there is another muscle. I'm sure you haven't heard of it, but this one is assisting your triceps. It is right under here, below your tricep muscle, basically. And it does actually assist. It is a synergist. Same here, you cannot isolate it. You cannot say you want to work only the acroneus today. Okay, so you see it's the same. It's just very little, small, very small. Okay, so basically it helps the tricep in order to stretch out or to do the elbow extension. So now this one is your shoulder muscle, which is your deltoid, and it has three parts. It has the front, medial part, and the back. Okay, so the origin are a little bit different from each. So the posterior, the anterior portion is the clavicle, which is here. Okay, which is here. And then the medial portion is your scapula and also a little bit your clavicle, which is here. And then your posterior is your shoulder blade, is your scapula. but all of them, all three insert into your humerus. Yeah, so because it does an abduction, it does an flexion, and it does an extension. Okay, so let's see here. So the first one is an flexion, and it does also an internal rotation. Okay, and when it does an internal rotation, of course, you do have also kind of like your lateral part as well. Lateral means medium. Okay, so it depends. When you only do this, it's only your anterior, but if you start doing movements, there are different muscles in your shoulder involved as well. So then the next one is going to be your medial or your lateral. It's an abduction. When you do, we are here now, when you do an overhead press, you're using all three. And when you do an, let's say an retraction, you will work your posterior part. Okay, so this is basically how your, or when you're doing a row, a wide row, you're working your posterior deltoid. Is it clear? Do I go too fast or everything is fine?
Can I ask a question, please?
Yes, of course.
This means, as you mentioned, we cannot separate one muscle in the shoulder from another, yes? This means if I play, let's say, front deltoid, I cannot separate it from mid one, yes? Also, the mid one will work, yes?
No,
there's no exercise
no.
focus
That's
on
not,
one, yes?
no, that's not what I said. That's not what I said. I said, when you do this, you're working only your anterior part. It does a flexion. But when you do this, and then you would do a different movement, then, of course, other parts of your shoulder will also do the work. Okay, so this one is your anterior one. Okay, when you do this, it's your medial part or lateral part. When you do this, it's your posterior part. But the same again, when you do this, there's also involved your rhomboids, because you're doing a row and you're squeezing your shoulder blades, right? There is a bit of your latissimus involved. There is your tricep involved, because when you do this, and remember we talked about the long head of the tricep is also actually going over your shoulder blade. But the main function of your posterior deltoid is a shoulder extension. The main function of your medial part is an abduction, and the main work or the main purpose of the anterior is a flexion in your shoulder. But when you do this, for example, you have all three parts involved. But of course, when you do this, it's also your traps are working. And when you do this, it's also your tricep working, because you're doing an elbow extension. You understand what I mean? So it's pretty complex. It's just like that the main function is this, and actually a flexion, an extension. Clear? Anything else? Somebody else wants to ask me? Speak to me. I'm here. Speak to me. Where's Adam? Is Adam here? Adam left? Okay. All right. Now let's talk about our pectoralis major, which is the chest muscle, is a big muscle. Okay. And as you can see here, the clavicle and the sternum, the clavicle is here, and your sternum, that is where your origin is. Okay. And its insertion is your arm. Okay, it's your humerus, right? This is the part where it's fixed and it moves your arm. It does this. Okay, so it does a shoulder adduction, and it does also an invert rotation. So when you do this, it also does an internal rotation of your shoulder. And That's the main part. But we have, basically the thing is you do have 3 parts of your pectoralis. You have the top part, you have the medial part, and you have the lower part. That's why sometimes you see people doing an incline bench press or a decline bench press or a flat bench press. Yeah. So it depends how you angle in your exercise. You will hit either more of the top portion of your pecs, medial part or lower part. Okay. But we will talk about that one tomorrow, how you actually can use the levers to your advantage, or how to use the levers for regression and progression. Okay. So let's see what it does. So this one is an example for your horizontal shoulder adduction. Yeah. So you're doing an adduction. You bring your arm, you bring your shoulder or your arm forward. Okay, so you do this, okay? And this one on your other side, this one is an internal rotation. Let's see again, okay? Okay. Clear? I move on? Okay. So the trapezius, same thing with your pecs, has 3 parts, the top part, medial part, and lower part. The top part is responsible for lifting up your shoulder. The bottom part, the medial part one, is to squeeze your shoulder blades, which is an adduction. So you're doing a retraction when you are retracting your shoulders, or you're doing an adduction. And it is all, the lower part is for a depression. Okay, so I show you this one. So this is your top traps. When you do shrugs, it's your upper traps working. Then this one is when you are squeezing your shoulder blades, it's called scapular adduction, because it brings it together. And then the last one is your depression. Okay, so basically these 3 parts do 3 different exercises or movements. Okay, so then the next one is your rhomboids. So the rhomboids is the muscle which connects your spine and your shoulder blade. Yeah, so you can see this here. So obviously this one is your origin, and this one would be your insertion. Yeah, and what it does a retraction, or again also a scapular adduction or retraction. So you're squeezing your shoulder blades this way, and when you see that one, this one is the one when you're with a downward rotation as well. So your shoulder blade does this. Check it out on your bottom part. Yeah, so this one is also an exercise, or not an exercise, not the movement. Okay, so when the muscle contracts, because the muscle, there are different. Yeah, so you have a major and you have a minor. Okay, so the major does a different movement than the minor. Okay, but in general, it's like you have to see the muscle fibers when they run this way. And when they're doing this movement, when they are, when they're contracting, and we remembered, we talked about that it pulls on a bone. So then we know what they're doing. Okay. So then if that one will contract, it will do a different movement than if those are contracting. Okay. Does it make sense? So I'll show you again. Wait just a second. Okay. Again. Yeah. So this is basically your scapular adduction, because your muscle contract, pulling the bone of the scapula together. Then this one, muscle contracts, pulling the scapula upwards. Okay. But these are the rhomboids. So basically all the exercises where you are doing, rowing or reverse flies. It assists also in lat pull downs. So they're all working everything where your shoulder blade is involved, because this is your shoulder blade, this is your spine, that is the muscle which connects them. Then this is your big muscle. This is also called the swimmer muscle, latissimus dorsi. And what it does is shoulder extension, an adduction, and also an internal rotation. So let's just check it out. So this is very simple. I mean, you will see, we will go through a lot of exercises because a lot of people in the gym doing nonsense training on the lat pull machine. So this is basically the one, you know, the lat pull when you're doing this exercise. And then what it does is also, check it out, it does also here, when you're doing, this is your shoulder extension. Yeah. So when you're standing on the, and you're doing a straight arm pull down, it works also your latissimus. And this one is the internal rotation. Yeah. So usually when you are training your latissimus, usually you do either this exercise or you're doing this exercise or you're doing a pull-up or something like that, okay? But the muscle does also this movement. That's why it's in your slide. But usually you would not go and do this exercise, what you just saw, the internal rotation, and say, oh, I'm doing now a lot. Yes, yes, yes. No, okay. That's not what we are talking about. This is not about exercise. This is now, we're talking what is the muscle, where is it located, and what does it do, okay? Besides of exercise, okay? All right, next one is your spine, is your erectus spinae, yeah? So it does an extension of your, oh, this is a lateral, this is basically your extension and lateral flexion, yeah? So when you're doing, let's say when you lie on your side, or when you're doing your obliques, for example, in standing position, it's not only your obliques working, it's also your spine is doing the exercise, yeah? So it does a lateral flexion and it does a normal extension. So that one is pretty straightforward, I think. So the extension of the spine and lateral flexion. So you have two movements, to the side and up in front, okay? Clear? Clear. If I go too fast, please stop me, okay? All right, so there's another muscle called serratus anterior, and that one is actually always helping or assisting when you do push-ups, when you do bench press, okay? And it depends when you're doing, for example, when you do a bench press and you go in your protraction, you are actually working a little bit more your serratus as well, okay? It depends on how you do the exercise. So I'm just going to show you what is the, you know, why do we have that muscle, okay? So it does a scapular upward rotation and also an abduction. So you see this one is an upward rotation, and an abduction means when you're doing a protraction, when you do this, okay? So there you go. All right, so that means if you, let's say when you're doing, do you know that little wheel, when you, an ab roller, you know, when you're doing an ab roller, when you do that exercise for your spine, and when you do the ab roller with a straight spine, you're working your tricep and you're working also your abs. But when you do the ab roller and you're doing a pronation like that, when you're protracting, protraction like this, you're actually involving a lot your serratus as well. So that one is always, you know, that's why it depends how you do the exercise, you can recruit more or less muscles, okay? Quite interesting, isn't it? Okay, so next one. This is our butt muscle. All right, this is a very expensive muscle for Jennifer Lopez because she has a huge gluteus maximus. Okay, let's go. Now, the butt muscle, gluteus maximus, what it does, it does an hip extension and an outward rotation of your leg. Okay, so the first one is your hip extension. right? And then the lower one, you see, it does an external rotation like that. You see? So it's just a small movement. That's why sometimes when you're doing a leg press, people say, okay, you should turn out your feet a little bit more so that you're working a bit more your glutes, okay? That's the reason why they say when you do a leg press, so usually your feet should be like that, but when you turn them a little bit more out, because then you do have an outward rotation, you're working a little bit more your glutes. But yeah, that's the reason. Okay, because it does two movements, and if you want to work very effectively, you better put your limbs in a position where you really have the most effective exercise out of it. Okay, does it make sense? Yes or no? Okay, I take it as a yes. Okay, so there is abductor groups. The abductor, as the name says, is responsible for a hip abduction, abduction. It takes the leg away from you, okay? And we have two of those. There are actually three. One is called gluteus medius. Then there is gluteus minimus. And we have another one is called tensor fasciae latae, and that is on the other slide, okay? So, but actually we have three abductors. One is medius, one is minimus. So one is bigger, one is a little bit smaller, but they do both the same thing, okay? So abduction is this one. And the same also here, okay? So it's just kind of like they are slightly overlapping over each other. But when you're doing, again, you can't really isolate those muscles because they have layers over each other, and then they're doing the same job. Okay, so the next slide is your tensor fasciae latae, which is also an abductor. It's a little bit longer, but the thing is that one goes all the way down, basically, over your ITB band to your, it will insert into your ITB band, okay? And your ITB band is actually attached to your bone in your lower leg, okay? So that one is actually also this little muscle here. The origin is here, and the insertion is it's your ITB band, which is a very long band which goes all the way down to your lower leg. Okay, and that one is also it does the same thing, and it does also a small internal rotation. You can see that later. Okay, so check this out now. I think this one is better, not this one. What it does, so you flex your hip and then it does an internal rotation. Yeah, so you better see this. So basically what it does, hang on, my dog is here in a minute. So what it does is it does this. I don't know if you can see that inside. Because it does this. Yeah, so it's an internal rotation. It's this way and that way. Okay.
Yeah.
All right. So then the inner thigh muscle are called adductor because they bring the leg inside. So adductor brings to inside. It brings it towards you. Okay. And it looks like this. Yeah. So when you're doing when you do your cable or your machine, so you bring your leg towards you. Okay, so this is your adductors. And as you can see here, it's actually also three muscles. It's called longus, brevis, and magnus. But when you know it's your adductors, totally fine. Okay, so nobody wants to know, or not really, you need to know adductor, longus, brevis, magnus, because as mentioned, you cannot really isolate them. You don't say, okay, today you do your adductor longus. Tomorrow I do my brevis, and then the day after I go for the magnus. Yeah, so no, you don't do that. You know, you're working your inner thighs and your outer thighs in one go, right? So that's basically what we do. Next, muscle. Okay, cool. So this is your hip flexor, right? So the hip flexors is actually you have a lot of more hip flexors, but that one is, I mean, we are not doing a Pilates, you know, course. When I did my Pilates certification, I needed to know all the muscles. So this is part of the hip flexor. It's called iliopsoas, and there are two. It's actually psoas major and minor, but that it doesn't really, it's not really important, okay? So you have two. One is psoas major, and the other one is minor, and the other one is iliacus. But iliopsoas is your hip flexor, and what it does is it flexes your hip. That's the name. That's why it's called hip flexor. Yeah. So what it does, again, when you lift up your leg, it is your hip flexor. Okay. So this is basically one of them. Of course, other muscles who are also inserting or origin in your hip, they will help. Yeah, when you do, let's say, when you do this, part of your quadriceps, because one of the quadriceps is also origin here, so will also be involved. Yeah, but the main muscle which is responsible for the hip flexion is that guy. Okay, the other one are just helper muscle. Okay, so now this one is your quadricep. Quattro is 4. Okay, so that means you have actually 4 muscles. One is the rectus femoris. That's the guy who actually goes over your hip. Yeah, you see, the origin is the ilium. That means when you are doing a hip flexion, that rectus femoris is also involved. Okay. The other one, we call them the vastis because it's lateralis, medialis, and intermedius. And you can see there are medialis is medium because it's into your midline here. Then you do have your lateralis, which is on the outside or the lateral side. And you do have the intermedius, which lies under the rectus femoris. Yeah, so you have 4 muscles in your thighs. Okay, so it's quite big. So front thigh, your quadricep, 4 muscle. Okay, so this one, what it does is the first one. This one is, it extends your knee. Yeah, so it does a knee extension. And because the quadricep, this one, the rectus femoris, is also going over your hip, it does a hip flexion as well. But only this one, the other 3, no, huh? The other 3 only doing an extension in your knee. Only that one also does a hip flexion, okay? Because that one is, this one goes on your ilium here, okay? And this is, yeah, this one is when you want to isolate it, you're just doing a knee extension, you're working your quadricep, all 4. That one is when you do a seated, let's say, leg extension, okay? But when you're doing a squat or when you're doing, you know, leg press, you're working more muscles. Yeah, but again, we're going into that one when we're doing our practical part. There's another one is called sartorius. This is actually your longest muscle in the body. It's the longest, not the strongest, but it's the longest. And you can see here, it also goes over your hip. So it is in theory also part of your hip flexors. Yeah. So this one is your sartorius. It's also called talar muscle, talar, because it's, you know, in the previous days where they were like tailors and they were like sitting on the street and sewing the, you know, pants and whatever, they're sitting like this. They're doing a tailor seat. They're doing this, right? And then they sit there and they're tailing, yeah? So this is the movement. You're doing this and this, that is your sartorius. I mean, part of it. Not all of it, but part of it, because Your abductors also involved, and your glutes is involved. Your but this is the main part. So it does a hip flexion, a knee flexion, and also an external rotation. So when you do an external rotation, the sartorius is involved. It's called talar muscle. It's just additional information for you. Okay. So, but again, the sartorius usually works together with others. So when you're doing any exercise where a hip flexion is involved, a knee flexion is involved, or where you're doing an external rotation, your sartorius is helping. Okay. You hardly go and train this muscle unless you have let's say an accident or an injury where you need to do physio, then I do special exercise for that one. But in a gym, we don't program exercises for sartorius. Okay, it's just like a muscle which is there. Okay, it's the same. You don't go to the gym and do this. Okay, normally we don't do that. If you have a lot of time, you can actually do this as well. Okay, so I mean we have a lot of muscles. Okay, good. Let's go now. Hamstrings. Hamstrings actually is also 4 muscles, even if you just see 3, but look at that. Bicep femoris. So bicep has 2 heads. That means bicep is 2. Then you have 2 more here, semimembranosus and semitendinosus. So actually, hamstrings has 4 heads of muscle. Okay, so it's biceps, bicep femoris, and the other 2. Okay. Now, what it does mainly, it does an knee flexion and an hip extension. Yeah. So this one is the main thing. So when you're doing an knee flexion, your hamstrings are involved. Okay. And because the bicep femoris also goes here over to the pelvis, that's the reason why those are also involved in the hip extension. Okay, so these are basically and also they're doing some when you're doing later when you see the exercises for your gastrocnemius, that one is also working for, because it goes over your knee. So they're going to the ischium, pelvis, ischium, and femur. So basically this hamstrings, semimembranosus, semitendinosus, they will be here on your pelvis, and the other one goes a little bit higher. Okay. But it's, as I mentioned, it's not important for your exam. So yeah, Yasmina, you wanted to ask something?
Sorry, I see only 3 muscles.
Okay.
You said there are 4?
I said it's 4 heads.
4 heads.
4 heads. 1,
okay.
2, bicep femoris. Okay, look at this. Whereas a bicep femoris has a short and a long head, right? The origin of the short and the long head, one is the ischium here. The second one is hidden here. You see that? Do you see this little thing here? Tiny one?
Yeah.
That's the one. Okay. So it is bicep. Bicep means 2. It has 2 heads. That's actually 4 heads. So you have 1, 2, 3, 4.
Yeah. Okay.
Yeah, it's the same as bicep brachii has 2 heads. Tricep has 3 heads. Quadricep is 4 muscle. Yeah. Okay. But it's not important. I mean, actually, it's 3 muscles, but 4 heads. So it's 3 muscles. It's bicep femoris, and then this 2. But because the bicep has 2 heads, it actually has 4 movements or 4 functions. See what you all learned. So we have another 3 muscles to go, and then you can go for your dinner. Woohoo! We are almost on time. Very good. Okay, so this is your calf muscle. It's called gastrocnemius. And what it does, remember, we talked about it, plantar flexion. Yesterday, I told you this is not a flexion in your, it's not called flexion or extension in your foot. It's called plantar flexion. Okay. So it does a plantar flexion. And because the origin, can you see, it goes over your kneecap. Your knee is here, knee joint is here. And the gastrocnemius goes a little bit higher here. And its origin is on your femur. That's why when you do a hamstring curl, you feel it also in your gastrocnemius, right? So it does a knee flexion and also a plantar flexion, but its main thing is plantar flexion, okay? So this way, okay? Next one. This is muscle. This one is also in your calf, but it doesn't go over your knee. You see, it stops here. The gastrocnemius was here. This one stops here, so, or you can see it here. So it's actually on the back of your tibia here. And what it does, it will insert in your Achilles tendon. Yeah, you see this one is your calcaneus muscle, you know, your calf, your heel bone, calcaneus, the bone of your heel. And this is your Achilles tendon. So it goes into your Achilles tendon. That's called, this is your soleus muscle. And this one is not doing any knee flexion. It only does the same what your gastrocnemius does, also a plantar flexion. Okay. Then the front part is your tibialis anterior, and it does a dorsiflexion this way. Remember, we talked about that plantar flexion, dorsiflexion. There you go. It pulls your toes upwards. Up. Oops, sorry. Okay, so I show you again. I show you again. Yeah, one more time. Up. That's a dorsiflexion, okay? So basically, if you would walk on your heels, that means if you would walk on your heels here, then you feel that actually that the front of your legs is very, very tight. Sometimes if you wear very, very flat shoes, or some of the Birkenstocks, you know, like the very flat kind of like health shoes, sometimes the heel is lower than your toes. What it is, people end up having shin splints, which is like an painful condition in the front of your muscle. This is because your heel is lower. You're doing all the time, you are in a dorsiflexion, and you always have a contracted tibialis anterior, which can cause an inflammation. Yeah. So this is sometimes when people, you know, some people cannot wear very flat shoes because they really get shin splints, really painful condition in the front of your feet. Okay. So we have only two more. So this is your rectus, this is your six pack, and then we have the obliques, I think, and then we are done. All right, so this is your six packs. And as you can see, we are not going into details because you do not need to know all the, you know, origin and the insertion and, you know, where is it exactly connected, or it's your seventh rib and your xiphoid process and stuff like that. You don't need to know that, okay? But what you need to know is what it does. It does a lumbar flexion, which is when you're doing a crunch, that is what you do, okay? So this is basically your superficial abdominal muscle, okay? Then your obliques. Your obliques, you have the external and you have the internal obliques. And what they do is they do two things. When you're doing your rotation, and also they're helping you with a lateral flexion, or a combination. You're doing a rotation and you're doing a flexion. Okay, so everything what you're doing in your oblique plane or in your horizontal plane when doing this, then they work together, okay? And it depends on which exercise you do. They're working either opposite together or they're working the same side. So for example, when you do this, when I'm doing, let's say, when I'm doing this, right? I'm working my external, internal on the same side, right? But when I go for a crunch, an oblique crunch, when I do diagonal, so when this one is my external and this is my internal, and I'm doing this, my muscle contracts like this. It goes short, it goes long. That means this is your external oblique, this is your internal oblique. And what it does, it will work the opposite side, okay? So they're working also together. So usually you can't really say you're only working your internal obliques or only your external obliques, because they are kind of like together, okay? So this is the movement, what they're doing. Yeah, you can see that they are sitting opposite. So you have the external here, one is here, external as well, and then here, but they only show one side. So they're showing this is your external, that is your internal, and of course you have the same thing on the other side. Yeah, so when you're doing, let's say, a Russian twist, or when you're doing, you know, like a normal twist, that one is how it works. So they're working external and internal, they're working together. Yeah, so they're going that way. Okay, and then you have your core muscle, which is your deep, 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 deep inside. This is the most important muscle when it comes to when we're doing, for example, pre-postnatal specialist course, or when it comes to Pilates. Okay, so this one is basically responsible for the breathing together with your diaphragm. So when you're doing kind of like a bracing movement, so when you're doing a Valsalva maneuver, which is a technique what bodybuilders using or powerlifters using, it's kind of like a brace. When you are bracing against your abdominal wall, when you compress and brace your abdomen, that is basically where your transverse is activated. Okay, so basically when you are not sucking in your belly button, not only sucking in your belly button, but drawing in the belly button and bracing together, that is actually what does, they call it here forced expiration by abdominal compression. So when you're doing, let's say, an Valsalva maneuver, I show you what it is. It's a technique, what they're using in order to overcome very heavy loads. Then they're using that muscle. Okay, so basically this one looks like you're just pulling in your belly button, but it is much, 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 much more complex. And we will talk and cover this when we go into details in core, because we have a topic which is core, and then we cover this one. All right, so I leave you alone today. So that's it for today. You did a good job. So tomorrow we will talk about the biomechanics. So tomorrow we're talking about the not biomechanics. Yeah, we're talking about levers. Okay, levers, and also prevention. Not prevention. What is it tomorrow? Okay, never mind. You just follow the book. Okay, so this is the next. This should be your next chapter: mechanics of movement and exercise effectiveness. So we're going through that one. And we will repeat a little bit again the key points, and I will give you on tomorrow evening, I will give you already kind of like some small kind of like exam questions where you can test your knowledge, what you've learned now already, okay? And what you can do is you can try out to answer them without the book, just to see if you understand them, okay? It's not yet a mock exam. It's just kind of like refreshing, you know, what we've learned and to summarize what we just covered, okay? So I think this is good. I think, yeah, 2.5, 3 hours is just nice. Normally we say we need about 20 hours. all together. But I think we will be fine. You're fine. Don't worry about it. That's good. And then maybe on weekend, if it is possible for those who are not working, because I know Angel has to work, but maybe Saturday, Sunday, if we could meet afternoon, it is a little bit better in terms of absorption, because it is a lot of information we need to understand and need to absorb. And I'm not too sure if it is a good idea to do that always in the evening, but I mean, it is just nice. I mean, I think we are all tired now, and it is not yet too complicated. Okay, I think you did understand everything well.
Simon,
Yeah.
you have mentioned about Saturday and Sunday.
Sorry,
afternoon.
wait, I need to put you in. Wait, I don't hear you. I forgot to put this in. Yes, okay. Now?
I see you have mentioned about Saturday and Sunday afternoon. I think it's a good idea because Sunday and Saturday I'm off day. And second thing, as you mentioned, now I need to go to gym now, you know. It's been very difficult for me, you know. I came back home 6. I attend the class now. Now I'm ready. I want to go to gym 9. I come back 11:30 or something. If
but
we
you
meet
see-
afternoon, Saturday and Sunday, nice.
Yeah. Okay, perfect. So, but I mean, we still continue. Tomorrow will be still evening because everybody is working. And then, you know, Saturday, Sunday, we are a little bit more off, I guess. So we can actually, we can discuss, we can see what time is okay. And I just hope that, you know, we try really to find a time where everyone can make it, because it's never a perfect time. But I mean, you know, you have to see, everyone needs to see what is important. You know, do you need to join this course online, yes or no? Or do you, you know, kind of like just want to watch this one, the recorded one? I mean, I'm not, you know, I'm just saying I'm here and you can ask me questions, but if you just have the recording, sometimes it's a bit difficult. And the problem is we don't have enough time for those who cannot live be and join. I cannot go back and, you know, repeat every time the same thing, or repeating the same thing again and again, just because some there couldn't make it. So that is the problem. So we try. I remember that you said that on Friday next week, you're only able to join at 11 o'clock, but that is not a big deal. I mean, that's 1 hour where you come late. That is not a big deal, but we need to finish this one first, and then I will give you homework and stuff until we see each other next week in person. And in person, I will tell you, it will be just perfect. Everything what we go through, everything will make sense, because you can touch the weights, you can, you know, try out, we're doing fitness testing, everything what we speak today in theory, everything will come together and everything will make sense. Okay. So even though yesterday you were like, oh my God, I think today already you were like, oh yeah. Okay, now I remember. So yesterday was maybe a little bit, you know, new, but today we repeated, and it's slowly, piece by piece, everything comes together like a puzzle. So I see you tomorrow. Again, if you have any questions, please text it in our group so that everybody can see what was your question. And then when I answer it, that we all can benefit of it. Okay. Alrighty. So good night. Enjoy your dinner. Enjoy your gym. And I see you tomorrow, 6 o'clock. Okay. Try to be on time. Okie dokie. See you.
Thank you.
I will share the session again tomorrow morning when it is converted. Okay.
Thank you very much.
All right. Good night. Bye.
Good night.